For the next part of this problem, we're gonna actually do some calculations. So for A, I wanna find the pH after 0 milliliters of base added. What this means is that I only have the acid present. What is present is only the 0.5 molar HX. And I simply need to find its pH. It doesn't matter how much of it it has. This is a weak acid, so weak acid is equilibrium. So I'm going to write a dissociation equation. I'm going to plug in my initial concentrations, my X row, we get to make the assumption that 0.5 minus X is basically still 0.5. Because X is going to be a really small value with a Ka value that's small like this. The College Board allows you to always make the assumption that X is negligible compared to your initial concentration of HX. And what that saves you from doing is the quadratic equation, so we can all appreciate that. Next, I'm going to write my Ka expression. Remember, your Ka expression shouldn't have numbers plugged into it. It should just be in terms of the reaction with no K value and no variables. So Ka equals H plus times X minus over HX. I'm going to plug in my 3.2 times 10 to the negative fifth equals X squared over 0.5. Solving for X, (3.2 times 10 to the negative fifth times 0.5, square root my answer, and I get the X to be 4 times 10 to the negative third. That is my H plus concentration, so I'll take the negative log of it to get the pH. So my starting point on this curve would be at a pH of 2.4. I'm going to write my answer here to keep track of them as we go. A good way to check your answers is, does the pH keep going up as you add more base? At no point should it go down.